Hello class, in this lesson we're going to learn about equations of tangent lines to circles. In our first example we have the equation of a circle, and we want to figure out the equations of tangent lines that have slopes of -1/2. So first let's analyze this equation. What's the center of the circle? What's its radius? Well, the center is going to be 3, 5, right? Take the opposite of these numbers. And the radius will be the square root of this constant. That'll be the square root of 20. And you can simplify that to 2 radical 5. You don't have to. Now we know that the tangent lines have a slope of -1/2. They tell us that in the problem. But what will the slopes of the radii be to those tangent lines? Well, when a radius meets a tangent at the point of tangency, what's the relationship between the radius and that tangent? They're perpendicular. And we know perpendicular lines have negative reciprocal slopes. And the negative reciprocal of -1/2 is +2. So we don't know what the point is on our circle. 2 points actually. So let's just call an arbitrary point xy. And we want to write two equations using xy and what we know. Well, we already have the equation of a circle. That's one equation. Let's write an equation with the slope. So we know that one of the points on our radius has to be the center, 3, 5. So if we use the slope formula with xy and 3, 5, we get this equation right here. Y minus 5 all over x minus 3 has to equal 2. And so now we have a system. And the goal is to solve it by substitution. And if you notice on the left-hand side, we have a y minus 5. Over here, we have a y minus 5 quantity squared. So it would be nice if we could rewrite this so we could substitute. So that's what we're going to do. So over here, we're going to multiply both sides by x minus 3. Right? We know that's not equal to 0 because this is equal to 2. It's not undefined. And so we get this equation. Okay, well, we want y minus 5 quantity squared, so let's square both sides of this equation. So 2 squared is 4, and then we get this binomial squared. And now we can substitute this entire expression for the quantity y minus 5 squared. And we get this equation. And now there's only one variable. And so now the goal is we want to solve it for x. And maybe your first thought is, okay, well, let's square these binomials, let's combine like terms and solve it. And that's one way to do it. But I think there's actually a slightly easier method. Now, what do these two pieces of the left-hand side have in common? They have the quantity x minus 3 squared in common. So we can factor that out. So remember, in front of this pair of parentheses, there's a 1 there, the multiplicative identity. If we factor out our common x minus 3 quantity squared, we end up with this equation. And 1 plus 4 is just 5. So this is a little bit simpler to solve. All right, so we're going to divide both sides here by 5. And now we take the square root of both sides. Remember, when we take the square roots, you have to have that plus or minus. So now we add 3 to both sides, and we get 2 answers. So x could be 3 minus 2, which is 1, or x could be 3 plus 2, which is 5. So now we want to figure out what the values of y are for these x values. But first, why are there 2 answers? Well, we want 2 tangents, right? And with the slope, you could have a tangent on one side of the circle. Now on the opposite end of the circle, have another line, tangent line with that same slope. So they're going to be, the points of tangency are going to be endpoints of a diameter. And so what are the coordinates now? Well, we know the x coordinates, and we know the equation of our circle, or we could also use the equation from our slope to figure out what the y coordinates are. So if we use slope, we just plug in 1 for x and 5 for x over here. Very similar process, just different numbers. Simplify, and then multiply and add 5 to both sides, and we get our points. We have 1, 1, and 5, 9. So these are the points of tangency. So now we want to make sure that our points are actually on the circle. So let's check that. Let's substitute our points and make sure that these work out. So try that on your own, and I'll show you my work. So both similar process on both sides. I know, are these equations true? And we end up with very similar equations. And once we square our quantities, they are exactly the same. And so we get 20 on both sides. So yes, our points are indeed on the circle. So now we want to find the equations of the tangent lines. Well, we have 2 points of tangency and we have a slope, so let's use point-slope form. That's one way to find the equations. So here's one possible set of answers. Or if you don't want to use point-slope form, you could use slope-intercept form. So we have our slope, we have our points, we got to figure out what our intercepts are. So we're going to end up with answers that are equivalent to these two answers. They're just going to look different because they're going to be in y equals mx plus b form. So we have our slope, -1/2. We have our 2 points. We multiply, and then we add 1/2 over here to both sides, add 5/2 over here to both sides, and we get our y-intercepts. And so we write our equations, and these are our answers. So these 2 blue equations at the end are equivalent to these equations here, just a different form. So here we have an equation of a circle, and we want to show that these lines are tangent to the circle. And we're going to say that the point of tangency we want is the point that we get from point-slope form. So how can we figure that out? Well, we need a couple of things. We can see here that the slopes of these lines, the slopes are both 1/3, same for both of them. So what would the slope be of a radius to the point of tangency for these 2 lines? It would have to be the negative reciprocal, -3. So we got to check that our negative reciprocal is that that the slope of the radii is going to be -3. We also want to make sure that our point of tangency is actually on the circle. So we got to check 2 different things. So first, let's just make sure that our points from point-slope form are on the circle. So let's say we have the point 6, -15, and the point -2, 9. Remember, it's the opposite signs for point-slope form. And so do these check out? Let's see. Very similar. And when we square them, these are exactly the same. And we get 160 on both sides. So the points of tangency are on the circle. Now we just have to figure out what the slope is of each radius. So we know the center of the circle. Center of the circle is 2, -3. So find the slope using that point and the points of tangency. And when we do that, we see that the slopes for both of them are -3. So the 2 lines are tangent to the circle. So in example 3, could this circle have these lines tangent to it? Let's see. We know we have to check to see if the points from point-slope form are on the circle. And it ends up that when we do that, that they are on the circle. However, these equations aren't for tangent lines because when we check the slopes, they don't work out. So the slope of the first line is -4/3. So the slope of the radius has to be +3/4. But when we figure out the slope of that radius, we get -3/4. So it's not a negative reciprocal, it's just a reciprocal. And the same for the other one. Here we have 3/4. And calculate the slope of radius, we get 4/3. Once again, it's just a reciprocal, not a negative reciprocal. So these are not tangents. In this lesson, we learned how to write the equations of lines tangent to a circle. Thank you for watching this video.